In this video, it shall be shown how to identify the region which graphically represents the solution of a linear inequality in one variable, and then for a linear inequality in two variables. Let us consider a very simple linear inequality, x less than or equal to 5. Our first step is to rewrite this inequality as an equation, x equal to 5. And we will now draw the line which represents x equal to 5 before we identify our region. Right, the line x equal to 5 is a vertical line passing through x equal to 5. Right, we now have two regions, one to the left, one to the right. We go back to our given inequality, x less than or equal to 5, and we determine which side of the line satisfies that region. Well, if we look at a point over here, all the points on this side have x coordinates less than 5. And so it is to the left of the line that is our solution region. Let us now consider another very simple inequality, y greater than or equal to 3. Once again, I change this into an equation, y equal to 3, and then we're going to draw the line which represents y equal to 3. Well, the line y equal to 3 is a horizontal line passing through y equal to 3. We now go back to our inequality. We want those points whose y values are greater than or equal to 3. We see that any point above this line will have a y value greater than or equal to 3. And so we can shade this area of the graph. Notice that in both of these first two examples, we drew solid lines because we were concerned with y greater than or equal to 3. If we were only concerned with y greater than 3 or y less than 3, then our line would not be solid, but would be a dashed line. The dashed line indicates that the point lying on the line is not in our solution. Now let us consider an inequality in two variables. For example, 2x plus 3y, say less than or equal to 12. Just like before, we'll change this into an equation. So we have 2x plus 3y is equal to 12. And what we want to do is to draw the line which represents this equation. Well, very easily we need to get 2 points which lie on the line. The simplest way is to first of all let's say x equal to 0, which tells us that 3y is equal to 12, y is equal to 4, and therefore the point 0, 4 lies on the line. If we now take y equal to 0, we get that 2x is equal to 12, therefore x is equal to 6, and this tells me that the point 6, 0 lies on the line. We then plot those 2 points. So we'll plot the point 0, 4 and the point 6, 0, and draw the line joining those 2 points. We now have to answer the question, which side of this line satisfies our inequality, 2x plus 3y is less than or equal to 12. And by inspection, if you choose any point on this side of the line, we will see that when we substitute those values into this equation, we satisfy this inequality. And so we have the shading shows the required region. If we had 2x plus 3y greater than or equal to 12, it would be on this side of the line. Okay, let's consider another inequality, x greater than y. Once again, change it into an equation, x equal to y, and draw the line representing that equation. Well, that will be a line passing through 0, 0, and at 45 degrees to each of the axes. So once again, we have two regions. We have to determine which one satisfies x greater than y in this case. And if I take a point on this side, I see that this point has coordinates, say 3, 5. So the x coordinate is greater than the y coordinate. And so this side of the line is our solution region. Our last example, we will consider x less than or equal to 2y. Again, I'm going to put x equal to 2y. And this is a straight line, so I need 2 points which lie on the line. So let us say, let x equal to 4. That would tell me that y should be equal to 2. So the point 4, 2 lies on the line. Let's say let y equal to 3. Therefore, x is equal to 2 times 3, which is equal to 6. Therefore, the point 6, 3 lies on the line. We'll plot those 2 points, 4, 2, and 6, 3, and draw the straight line which passes through those 2 points. Now once again, we have two regions. We have to determine which one satisfies our region. We want that x is less than 2y. So let's choose a point over here. Let's take this point 7, 2. And we say if y is 2, 2 2s are 4, but x is 7. And so this satisfies the inequality at x less than or equal to 2y. So we've considered a number of cases of being able to draw the graphs of linear inequalities. In the next video, we will show how these are put together in solving a typical linear programming question.